supernovas. As this time-lapse view of the Milky Way shows, stars explode fairly often, at a rate of about 2 per century in a galaxy like ours. So, if you observe enough galaxies, you can spot a new supernova every few nights. The observers were especially interested in a particular type of supernova, like this one, where the corpses of 2 dead stars orbit each other so closely that they eventually collide and detonate. Such supernovas are very bright and consistent in brightness, providing scientists with an extraordinary tool for measuring cosmic distances across the universe and back through time. By measuring the distances and speeds of hundreds of supernovas, the astronomers learned how fast the universe was expanding billions of years ago. By 1998, to their astonishment, they found that the universe hadn't expanded faster in the past as expected. Just the opposite. It used to expand more slowly than it does today. The expansion rate isn't slowing down, it's speeding up, accelerating. And it's been accelerating for the past 5 billion years. The pressure causing the acceleration is called dark energy. But that's just a label. Nobody yet understands dark energy, though it appears to be powerful enough to shape the course of cosmic destiny. Matter and energy are 2 sides of the same coin, as Einstein revealed in his famous equation, E equals mc squared. In those terms, dark energy weighs in at nearly 70% of the total stuff of the universe. Dark matter accounts for almost all the rest. Normal matter, all that we are, or all that we've ever seen or touched, amounts to less than 5% of the known universe. So we know precisely when the universe began, and we're beginning to understand what it's made of. But how big is it? Our observable universe is limited to the part of the cosmos from which light has reached us here on Earth. But every galaxy occupies the center of its own observable universe. Observers in this distant galaxy can see light from regions we cannot yet see. And we can see regions they cannot see. So no matter who or where you are, you reach the same conclusion: that the universe as a whole must be bigger than the part of it you can perceive. How much bigger? Some scientists speculate that if the observable universe were the size of a planetarium dome, the entire universe would be larger than planet Earth. Others suggest it may be infinitely large. Clearly, there's more to the universe than meets the eye.